Hello there guys, and welcome back to another epic inexorable maths video. In this video we're taking a look at the simple question of why on earth is 0 factorial equal to 1? That is a known fact, that's true. You can try on a calculator. If you have a calculator, maybe like this one here, there's a button on it. You can put 0 and then you can do 0 factorial. There's a button for that, and it does indeed tell you that 0 factorial is equal to 1. We also know that it's definitely equal to 1 because there are many formulas that rely on it being equal to 1. For example, the formula for Maclaurin series, you need to divide by 0 factorial. And if 0 factorial was, maybe you might assume 0 factorial would be equal to 0. That's a problem for dividing by 0 factorial. You can't divide by 0. So just to be very clear, when we say 0 factorial or n factorial in general, for some whole number that's a positive whole number, we call those natural numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. For one of those numbers, that number factorial, we'll call it n. N factorial is equal to n times n minus 1, n minus 2, n minus 3, all the way until we get down to 1. So for example, 5 factorial would be 5 times 4 times 3 times 2 times 1, which is 120. 0 factorial, though, is equal to 1. And this video is about why that is the case. So there's multiple ways to do this. You can do it using sort of combinatorics and just kind of thinking about the what does 0 factorial actually mean? What does it represent? It's talking about combinations. How many combinations of 0 things do you have? Well, I guess you can just have 1, so that's one way, but it's not very rigorous. It's not a very good proof, in my opinion. I think the best way, the easiest way, the clearest way is to look at the pattern of the factorial numbers. So this is how I would prove that 0 factorial is equal to 1. First things first, let's just look at some numbers. So let's look at 1 factorial, right? What is 1 factorial? 1 factorial is 1 times every number until you get to 1, which is 1. 2 factorial is 2 times every number until you get to 1, so 2 times 1, which is 2. 3 factorial is 3 times 2 times 1, which is 6. 4 factorial is 4 times 3 times 2 times 1, so it's 24. And you can keep doing this. We can do a few more. 5 factorial, I've already said, that's equal to 120. 6 factorial, that's 6 times 5 times 4 times 3 times 2 times 1, that is equal to 720. 7 factorial, that is equal to 5040. As you can see, these things are getting bigger and bigger and bigger pretty quickly, and that is the case, right? So here's how you actually do this. Let's look now. I'm going to write above the 1 factorial. I'm going to say 0 factorial, just like this. And we don't know what it is yet. We're going to assume that we don't know that it's 1. Maybe you don't know. That's what we're trying to prove, right? So in another colour, in purple, here's what we'll do. We're going to look at what you have to multiply the first 1 factorial by to get to 2 factorial. Well, to go from 1 to 2, you have to times by 2. So 1 factorial to 2 factorial, multiply by 2. 2 factorial to 3 factorial, well, how do you get from 2 to 6 using multiplication? Well, you times by 3. Okay. 6 to 24, what are you timesing by there? Okay, you're timesing by 4. You're timesing by 5 to get from 24 to 120, and so on. And of course, that means that you can go backwards too. So let's look on this side. What we'll do is we'll say, how do we get from 5 factorial to 4 factorial? How do we get from 120 to 24? Well, we divide by 5. How do we get from 4 factorial to 3 factorial? Well, we divide by 4, right? 24 divided by what is 6? Well, we divide by 4. We're just going backwards, right? So if we times by 4 as we go down the list, we divide as we times by some number as we go down the list, we divide as we go back up it, because we're doing the opposite thing, because we're going the other way. How do we get from 6 to 2? Well, of course, we divide by 3. How do we get from 2 to 1? Well, we divide by 2. And this is the leap, right? If we follow this pattern, how do we don't know what 0 factorial is, but look at the pattern. It's divide by 5, divide by 4, divide by 3, divide by 2. What should we divide by next? I'm going to say we probably should divide by 1. Let's divide by 1 to get from 1 factorial to 0 factorial. And likewise, if we look on this side again, what's next? Well, to go from whatever 0 factorial is, we don't know what it is yet, we're going to assume, to go from that number that we don't know to the number 1, we need to times by 1. Because look, in yet another colour, like this all makes sense. This is in a sequence of numbers that makes sense. And same with this side, right? Like it's just numerical values. It's got timesing by, 1, then 2, then 3, then 4, then 5, and so on, and dividing as we go the other way. So of course, what is 0 factorial? We go from the number 1 to or the number 1 factorial to number 0 factorial. This is telling us we need to divide by 1. So we need to do 1 divided by 1. And what is 1 divided by 1? That is nothing other than 1. And again, let's check it. Let's go the other way. Let's start timesing again. 1 times 1 is 1 factorial. Looks good to me. So it fits into this pattern. That's the best way to prove, I think, that 0 factorial is equal to 1. Look at the pattern. As you increase in your factorials, you start timesing by increasing natural numbers, 1, 2, 3, 4, 5. Go the other way, take it to 0, and there you go. You have got 1 factorial. Is that a rigorous mathematical proof? No, but it's a very, very good one for conceptualizing it and visualizing it. And I think it makes enough sense to be satisfactory as to why 0 factorial is equal to 1. Thank you guys so much for watching. I highly appreciate it, and I'll see you in the next video. Cheers.